Hi everyone, I'm Karan, a PhD student from the University of Toronto, and today I'll be talking about our work on painting with 3D Gaussian Splat brushes. This is joint work with my awesome collaborators at NVIDIA under the guidance of Masha Shugrina and my advisor, Karan Singh. So artists and designers use real-world references for a variety of creative tasks, whether it's inspiration for character design, concepts for a fantasy world, or even concrete engineering designs that mimic nature. But having been inspired by these awesome things, the process of using reference often consists of a slow, tedious manual replication of features a creative user likes to capture from captured elements, with this process being repeated for then each project and source of inspiration. That's what makes modern 3D reconstruction exciting for creative people. Digital capture and representations like 3D Gaussian splats are bringing us closer to faithfully capturing the real world. With more direct artistic access to real-world texture geometry content than ever before. Unfortunately, as good as these captures look, they're often locked in place, restricted to viewing with few avenues for creative play. Avenues that do exist are slow and indirect, like text-based edits that take minutes to run, or those that limit their focus to physics-based animation and deformation. What we're essentially missing is this real-time ability to directly create with elements in captured scenes, to close the gap between reference and inspirational play and kind of let our imaginations run wild with elements from the real world. Motivated by this challenge, we present Painting with 3D Gaussian Splats, the first real-time interactive tool to paint seamless, coherent structures with subsets of 3D Gaussian splats. From building structures to textural overlays or spraying natural variations, our tool supports a variety of creative workflows while giving precise real-time controls to a user, effectively allowing them to remix reality. So let's talk about how we do this. Our method is built upon the basic ability to build coherent, seamless strokes from a selection of Gaussians in real time. We achieve this in 4 basic steps: selecting and orienting Gaussian stamps, placing them along a user's painted strokes, deforming them to fit the shape of the stroke, and finally in-painting artifacted seams. Let's start with selection. Given the recent interest in Gaussian splats, there's a variety of tools available for selecting meaningful subsets of Gaussian splat scenes, ranging from an in-house iterative bounding box selection imbued with set operations that comes built in with our tool, or brush-based selections with supersplat and semantic object or material-based selections with recent research. Once we've selected our subset, like so, we then orient the Gaussian stamp to define the forward and up directions for the painting. Now that we've selected and oriented our Gaussians, we have our stamp and are ready to paint. The first step in the painting approach is to do a simple rigid placement of stamps along the user's stroke. To do that, we first need a representation of the user's stroke in the scene. We estimate a set of first hits and normals following along the user's brush as they paint, and then interpolate both of these quantities using a cubic spline. Now we have a spline of the actual stroke in the scene along with the estimated normals along the stroke. We then simply place the stamp along the computed spline, aligning its forward and up directions defined by the user set orientation with the spline tangent and normal via simple rigid transforms. So as you can see in the image here, in the second column, all we've done is build a representation for the user's stroke and duplicated the stamp and used a set of rigid transforms to place it along the stroke. Clearly, this isn't good enough, so now we'll apply a non-rigid deformation to each of these individual stamps that we've pasted along the stroke. The non-rigid deformation we use is really simple actually, just transferring each Gaussian location and orientation from the stamp's local coordinate frame to the spline's coordinate frame. So essentially, if a Gaussian is located at some 3D coordinate relative to the stamp's origin and has some 3D orientation relative to the stamp's orientation axis, all we do is now figure out, oh, what if we followed the same coordinates but now along the spline's axis, that is its tangents, normals, and binormals? Where would we place this Gaussian and how would it be oriented with respect to these axes? One of the key insights of working on this actually was that surprisingly, doing this non-rigid deformation already takes you quite far. For a variety of structures with default parameters for the spacing of the stamps, nothing smart there, Gaussians being these explicit blobs in 3D with the way they're rendered and blended, this smart positioning and deformation strategy already gives us a very coherent looking structures in a lot of cases. However, of course, there are examples where this won't be sufficient, like stamps with heavy textural influence or heavily asymmetric parts that simply don't fit together. So now what do we do? We, of course, in-paint the seam artifacts with an image-to-image diffusion model. We have a simple setup where we use a couple of cameras, a top and side view, and optimize largely appearance-based parameters such as the opacity and the spherical harmonics to preserve the 3D structure of the stroke. We found that not only is this sufficient for numerous examples, but achieving satisfactory results on even simple cases with the full parameter set for the Gaussians need a much more heavyweight setup with multiple cameras and a multi-view consistent diffusion model and more optimization time. So now I'll talk about the video that's been playing for a while. Even with the lightweight setup, in-painting and optimization struggles to be real-time. So we preserve real-time interaction by kind of running this process in the background, replacing modified Gaussians as and when they're ready and optimized. So we see in the video we've painted something, now we're painting somewhere else. Now when this is in-painted, we go back and we see the in-painted version. The in-painting algorithm opens a new avenue of creative applications. When we start speaking of in-painting and blending portions between stamps in a stroke, a natural question is what happens when different painted strokes interact. Our in-painting implementation extends to this use case simply by allowing now these Gaussians to move through each other and shifting the in-painting camera's target onto the intersecting Gaussians between strokes now, allowing a new set of applications like crossroads and extensions. To summarize, we build seamless strokes from subsets of Gaussians with a 4-step process. Estimate first hits and normals to build a user stroke with normal information, duplicate and rigidly place-oriented stamps along the stroke, perform a non-rigid deformation to bend the stamps along the stroke geometry, and finally in-paint artifacted seams. Beyond basic painting, we provide users with additional controls to get more of the same selection stamps. Controls such as jitter in both scale and orientation and spacing allow users to achieve strokes with different looks or paint regions with natural-looking randomized variations, as we can see in this example. Additionally, we support painting in free 3D space. To do this, we use mesh proxies to define first hits and normals, thus allowing for fun creative examples like these ones where we can paint birds around a lighthouse or repair a half-eaten gingerbread house. Overall, the combination of a seamless real-time painting experience and a suite of creative controls and brush parameters allows for a range of creative applications. Whether it's repairing your favorite captures, building whole new environments, or reimagining captured scenes, Splat painting can help you do it all. We evaluated the tool using a semi-structured user study with animation industry professionals who not only picked up the tool quickly and painted scenes like these ones, but also reaffirmed the value of such realistic, rapid prototyping for concept visualization and pre-production. In conclusion, we present the first real-time interactive painting tool with 3D Gaussian splats, which allows users to seamlessly paint both coherent structures and rich, organic, natural landscapes with beautiful captured stamps. Further, we allow users the creative freedom to remix reality with captures on their own terms, whether it's by turning photorealistic stamps into their own stylistic brushes via a set of brush parameters or painting freely in 3D via surface proxies. All of that said, there's still lots to do. Baked lighting in 3D Gaussian splat captures precludes us from that truly seamless experience of capturing elements at a bunch of different times and places and painting them coherently into the same space as differently lit captures stand out in the scene. Another interesting direction is, of course, that if you're painting with reality, each of these brushes have semantic meanings and behaviors. Could we incorporate that into the painting process somehow? Finally, we miss a whole set of creative controls, like erasing, working in layers, before we truly have a Photoshop for 3D realistic captures. Thank you for listening to me talk about our work. Feel free to keep up with the broad accessible releases of this tool via the mailing list, or check out the paper and future code releases on our website. We'll be demoing the tool tomorrow evening at Real Time Live in a fun demo, and you can demo it yourself on Thursday morning at eTech. Thanks.